Today's lesson is on section 4.7, solving linear equations using graphs. And so we're going to do three steps basically here. And these are problems that we're typically used to solving by just isolating a variable and then coming up with our solution, but we're going to look at how to do it graphically as well. So our first step is to write the equation in the form ax plus b equals 0. So in other words, gather all the terms on one side of the equal sign so that the other side of the equal sign has nothing on it or just a 0. Then after we do that, we're going to write the related function. So we're going to write it as y equals ax plus b. In other words, we're going to substitute y in for 0. Once we do that, then we have a linear equation that we can graph. It's already in slope-intercept form at that point. So then we're going to graph the equation. So when we graph the equation, the solution of the equation, or what x equals, is the x-intercept of that graph. So those are our three steps. We're going to look at them more specifically in this next problem. So this first problem, 3x minus 2 equals 4, we're going to first solve it algebraically, which is what we would typically do. So we're going to add 2 to both sides and then divide both sides by 3 so that we come up with a solution of x equals 2. That's what we're used to doing so far, and that's perfectly acceptable, except for we want to look at how can we solve this with a graph, because it helps us to interpret and understand what the graphs are really meaning. So graphically, what we would do is we would go ahead and solve that equation by gathering all of the terms to one side. So we're solving it and making it equal to 0. So that's what I've done here in this first step. I subtracted 4 from both sides, so I have 3x minus 6 equals 0. Then in place of the 0, I'm going to write the y. And so I just switch the order so that because I'm always used to seeing the y first, so I just put the y on the left. But that 3x minus 6 doesn't change. So now I have y equals 3x minus 6. So now I have my slope and my y-intercept. So I'm going to go ahead and I'm going to graph this on a graph. And when I do that, I plot my y-intercept all the way down at the bottom there at negative 6. And I count my slope, which is 3. So that means I rise 3 and run 1. I rise 3 and run 1 again, and I can do it again. And so I come up with this line that you see here. Now the x-intercept, which I have circled on this graph, is the solution to that equation. And so we have x equals 2 when we solved it algebraically, and that graph crosses the x-axis at positive 2. So that just verifies that our solution is indeed correct. So let's look at another example. This time we're just going to solve it graphically. So I have the equation 5 halves x minus 1 equals 9 halves x. So again, I want to solve it to make it equal to 0. So I'm going to take the 9 halves x away from both sides. So I have 5 halves x minus 9 halves. They both have a common denominator already. So I do 5 minus 9, which is negative 4, over 2x minus 1 equals 0. And then negative 4 over 2 is negative 2. So I simplify that, and so that's where I get that this step number 1 here is by simplifying. So I have negative 2x minus 1 equals 0. Then I'm going to substitute y in place of 0, and so I have y equals negative 2x minus 1. And then I'm going to graph that using my y-intercept of negative 1, which you can see I've plotted on my graph. And then I count my slope. Because it's negative, I go down 2 and right 1. Or I can go up 2 and left 1. One of my movements has to be negative. And remember, a negative movement is either left or down. And then I look at my graph and I see that that line crosses the x-axis at negative 1/2. And so that would be my solution to that second equation here of 2/5 x minus 1 equals 9 halves x. The solution to that equation is negative 1/2. And I could also check that algebraically. So here are two problems I'd like you to try on your own, and I'd like you to solve them graphically. Of course, you could check them algebraically. I would not have a problem with that at all. Or you could just take the solution you get and substitute it in place of x to see if you come up with two equal sides. But go ahead and solve these graphically, which means I want you to go through the three steps. One, write the equation in the form ax plus b equals 0, so gather all your terms on one side. The second step, change the 0 to a y, so now you have a y equals mx plus b equation, or an equation in slope-intercept form. Then go ahead and graph it. And remember, the solution is where it crosses that x-axis. So have those two problems solved, obviously with a graph, tomorrow for class, and we will go over them together. Have a good night.